Good afternoon and welcome to the Model High School data overview that has been prepared for the mathematics department. I'm so glad that you were able to join us today, and I hope that you benefit from this presentation and that ultimately your students will as well. The purpose of this presentation is to review demographic changes at Model High School that have occurred over the last 4 years, along with the demographic changes at the feeder schools. Just thought that might be interesting data to look at to see if the trends in the middle school and 2 feeder elementary schools also kind of mimic the changes that are occurring at Model, the high school. We're also going to specifically examine coordinate algebra, algebra 1, and analytic geometry results on the EOCT and EOC standardized assessments over the last 3 years. We're going to have to look at these different subject areas and tests due to the changing of the curriculum and the tests in Georgia. We'll talk a little bit more about that. We're going to analyze Algebra 1 and Analytic Geometry domain strand data to give a better idea of what content specifically are our students struggling with or have they mastered. Identify strengths and weaknesses in both Algebra 1 and Analytic Geometry data, and discuss changes in instructional practices for next year in the classes that we teach that have EOCs in an effort to raise those student achievement scores. So when we're looking at the enrollment data of Model High School over the last 4 years, it hasn't really changed much. We had 648 students during the 2013-14 school year, and as of last week we had 667 students, which is exactly how many we had at the end of the 2015-16 school year. So we've seen a slight increase, but not significant. That's the trend in most of our feeder schools as well. If we look here, we have Johnson at the bottom, Model Elementary, Model Middle, and then this is the data you just saw from the high school. So the middle school has grown a little bit more considerably, 514 2 years ago, 582 now. But the elementary schools, Johnson has decreased and Model Elementary has increased a little, so or decreased and then increased again. Sorry about that. So pretty much right in line with the trends that we're seeing in the high school. So we can anticipate maybe a little bit of fluctuation as these elementary middle school students move up to the high school, but not a significant jump is going to happen. Going back to just looking at the high school, we serve 9th, 10th, 11th, and 12th graders here, and if we look at the data over the course of the last 4 years, the 9th graders jump around the most. The 12th graders, we finished the years with about the same amount of 12th graders. We do have our biggest graduating class in these 12th graders, and if we stay on trend, then we might have an even bigger class when our 11th graders get here, assuming students stay and finish and all that. But we start off with more 9th graders. Some of them drop out by the time they're 12th graders or maybe pursue other options, and we just need to be aware of that. And the fact that this presentation is going to focus on mostly or on the 9th and 10th grade math classes means that these are the students that some of them don't make it, they do drop out. We need to be aware that how we structure our classes, how we teach, and the performance of these students could have an impact on them making it to this 12th grade year. The students that are sitting in our school right now, 27% of them are 9th graders, 22% of them are 10th graders, 27% of them are 11th graders, and 24% of them are 12th graders. So we've got a pretty even distribution. 10th graders are our smallest percentage, but no significant percentage in any specific grade level. As far as our ethnicity goes, we have definitely a predominant Caucasian population. 84% of our students are Caucasian. And these little pie pieces are a little hard to read, but the 0% goes with the American Indian or Alaskan Native category. We actually only have 2 students that fall into that range, and that is not really enough of a percentage to register. Then the Asian percentage is the 2%. We've got African American, which is our 8%, and then Hispanic Latino, which is our 5%. And if I remember correctly, this 1% is 2 or more races. For some reason that didn't show up down here, but 2 or more races is the 1%. So not a huge population that is not Caucasian, but there is some diversity within our school. Now, specifically what this presentation is about is our testing information and how we can see improvement in the scores that are so important for teacher evaluation purposes, for students being successful, for their grades, they go in their transcripts, all those things. So just a few reminders about these tests. 2 years ago, Georgia began administering the Georgia Milestones in the specific courses that we have end-of-course tests in. Previously, we administered EOCTs. They were not called Georgia Milestones, and we scored students in 3 categories. Did not meet, which was a scaled score, a grade that we normally give on a scale of 0 to 100. The did not meet grades were 0 to 69s. Students that met expectations, their grades were between the numbers of 70 and 89, and exceeds was 90 to 100. 2 years ago, we changed to Georgia Milestones, and they report scores in 4 different levels: a beginning learner, developing learner, proficient learner, and a distinguished learner. And you can see the different scores there on the scaled score scale from 0 to 100. The Georgia Milestones test is supposed to be significantly more challenging than the previously administered CRCTs in elementary and middle school and the EOCTs that we were giving in the high school. So it's harder, we assumed, for students to fall into these upper categories. Also, the goal target is not meets anymore, so we don't want our students to just be in that developing learner section. We want them to be in the proficient or the distinguished learner categories. So we're shooting for an 80 on these tests, not just a 70 like on the previously administered standardized assessments. Another thing to keep in mind as we're looking at this data is that Floyd County moved from Coordinate Algebra to Algebra 1 last school year, so during the 2015-16 school year. We currently teach geometry this year, and previously we were teaching analytic geometry. So as you look at these graphs and this data, pay really close attention to the titles because they're telling you what specific test are you looking at, and that's going to sort of dictate how you need to interpret that data. Okay, moving on. Let's look at some information. We've got our coordinate algebra EOCT score. So this was before we had moved to Georgia Milestones. This was the old test, but for longitudinal comparison purposes, we're going to look at this. And I've split them up by state, county, Floyd County schools, and then Model High School with the total number of students tested. But we're reporting this data in percentages. We've got our does not meet, meets, and exceeds. And you can see here that in 2013-14, a significant number of Model High School students did not meet the expectations in the coordinate algebra test. 26.8% were a little closer to the Georgia and Floyd County schools percentage, but still below it, and we are significantly below it in the exceeds category. So we had some work to do. It was not the best performance there. We got a little better when we moved to Georgia Milestones, which was a little surprising given that the Georgia Milestones was supposed to be a harder test. You've got beginning learners, developing learners, proficient learners, and distinguished learners. They go in order from lowest to highest in each of these categories. 2014-15 EOC with coordinate algebra, and then last year the Algebra 1 EOC administration. So you can't really compare these two side by side because they weren't the same test. the Algebra 1 was testing more standards than the coordinate algebra was. Knowing that, it's also good to see that our scores did increase even though the test was harder. And so you can look here and notice how we compare to Georgia and also how we compare to Floyd County schools for both years. Getting a little more specific for just Model High School. This is comparing the two tests side by side. Again, it's not necessarily the best comparison, but given we only have 1 year's worth of Algebra 1 data, it's really all we can do if we want to look for some of these trends. So we've got our distinguished learners up top, and then the top bar is from the Coordinate Algebra Administration, 2014-15, and then the bottom bar on each performance level is the Algebra 1 administration from last year. So we've got our distinguished, proficient, developing, and beginning learners. And you can notice that last year our distinguished and proficient learners went up, which was great, and our developing and beginning learners went down. And that's the goal. We want the bottom two levels to decrease in percentage while the upper two levels increase in percentage. And we moved in that direction. And then just getting a little more specific, we can drill down to our domain data. There's like mixed feelings on whether or not this data is really valuable because we only test our students on so many questions per standard. So is this really a good data set for us to use to guide instruction? But it probably can't hurt. That's sort of how I think about it. And so we've got our 4 main strands of the Algebra 1 standards. Those are functions, expressions, equations, and statistics and probability. You can see here that the majority of our students need remediation in functions. We're going to talk about why we think that is in a minute. And then we've got our expressions, equations, and statistics and probability domains as well. And then the percentage of students who need to be monitored and accelerated. And so that data can just be helpful to look at and figure out where do I need to focus my attention? Which units need the most time when I'm preparing my curriculum? Where do I need to make sure I spend my time as I review for my EOC? So the domain data can just give you some more instructional information, maybe more so than a bigger picture when you're thinking about your class in general. Okay, so I want you to take a second and talk about it. Whether you're sitting by someone who teaches algebra, you teach algebra, but discuss what trends do you notice in the Georgia milestone data that we have for coordinate algebra and Algebra 1. So I sort of discussed some, but what do you notice that I didn't point out? What changed in your classes, specifically if you teach Algebra 1 between 2014 and 2015, that it could account for the increase in these distinguished proficient percentages? What did we do right? What did Model High School do that made these percentages increase? If we can figure out what we did that worked, we could do that again and hopefully see that same increase. And what do you take from the domain data? Do you think it's useful? Is it something you would want to know specifically for your students? We only have domain data that's available from the last year on the tunnel, so if it's something you want, we're going to have to start keeping up with it ourselves. So take a second, look at the handouts that you have, and talk about it. Okay, thank you for doing that. That was coordinate algebra. Hitting the high points on that. Now let's think about analytic geometry. Again, we gave an analytic geometry EOCT 3 years ago. This is the comparison between the state of Georgia, Floyd County Schools, and Model High School. We are above the state percentage in not meeting standards. We were above, and we were a little bit below the county, which was great, and a little above the county in meets and exceeds, but still below the state. So we weren't quite up to where the state average was, but we were exceeding the county average, so I guess that's always good. But again, that data is not necessarily useful anymore. We don't use that data. We've transitioned to milestones. So here we have the 4 different proficiency levels, again, compared by state, county, and school. And so we can look at the trends, and hopefully we see an increase from 2014-15 to the 2015-16 administration in the proficient and distinguished learners. Those are the last 2 bars, and we do see an increase in that. We also see an increase in the developing learners, which isn't necessarily ideal, but when you look at this beginning learners, you can see a significant decrease, which is the goal. And as you compare across the county and the state, we are above the state and the county in proficient, above the state and the county in meets, or in distinguished, excuse me. In 2014-15, we were above the county in proficient and above the state, and we were above the county in distinguished, but a little bit below the state. So not quite where we wanted to be in 2014-15, but we made some changes, I assume, and we've made it to where we're above the county and the state in our last administration. These data sets are easily comparable. They were the same test, or testing the same standards. Now next year, this year, we've taught geometry. So when we're looking at data next year, we're going to be kind of comparing apples and oranges, because geometry, we lost some standards. They moved to algebra. So hopefully we'll see an even bigger increase, but we won't know until we're actually looking at the scores and can drill that data down as well. Again, this is just looking at model in general. We've got the number of students that we've tested down here, and the 2014 is our top bar, and the 2015-16 is our bottom bar for each performance level. Again, we want to see increase in the top 2 levels and decreasing in the bottom 2. We saw an increase in the top 2. We also saw an increase in developing learners, but we saw a significant decrease in beginning learners, which means some of these 1s have moved to 2s. Hopefully some of the 2s are moving to 3s and 3s are moving to 4s. So we're making progress. We are moving in the right direction, which is definitely better than moving in the opposite direction. And then looking at the domain data, analytic geometry has a few more domains. It should back down when we're looking at data next year, but for now we have 5. Congruence and similarity, circles, equations and measurement, expressions, equations, and functions, and statistics and probability. We've got some standards that need some remediation. Over 51% of our students struggle with congruence and similarity. That surprised me. When I think about the geometry students I've taught, they tend to excel in that area, but according to my data and the school data, they didn't. So that's an area that needs to be focused on. We also have some areas that we could accelerate some students in. And 29% of our students are good on expressions, equations, and functions. So maybe that's something we don't need to spend as much time on. We've got this monitor category. Again, this may or may not be very useful. I would find it useful in my classroom, but you might not, and that's okay. But we've got to be able to figure out specifically what do our kids need to work on. So whether or not we use the domain data or another data source, we've got to drill down to specifically what are our kids struggling with so that we can meet that need and help them be successful. Now, you heard what I think about it, and I want you to take some time again to talk about this geometry data. So what do you notice? What trends do you notice in the Georgia milestone data that we have? The ones I pointed out, discuss them a little more, or come up with some on your own. Think about what you did, whether you taught algebra and then you saw an increase in their geometry scores, or you taught geometry both years. What changed in your classes that could account for that increase in our distinguished and proficient percentages and a significant decrease in our beginning learners? And what do you take from the analytic geometry domain data that we have from last year, and how can that guide your instruction? So take a few minutes and talk about that. Okay, as I look at the data, three things sort of pop out to me that need improvement. And the first is that our Algebra 1 and Analytic Geometry scores indicate that we need to find ways to identify our students' weaknesses so that we can move more of them to proficient or distinguished learners. That's where that domain data comes in. Whether we use that or not, we have to find a way to pinpoint our students' weaknesses so that we can fill those gaps and move them in the direction of being a proficient learner. Students in Algebra 1 and Geometry are more successful on the domain strands that closely align to middle school standards. So we need to go through and look at them. What have they already covered in middle school? And build on that, but don't focus on it so that we can spend more time focusing on what they're less familiar with. And from the data, it seems that Algebra 1 needs more attention than Geometry. For whatever reason, that's where we need to focus our efforts of improvement so that we can ultimately see an improvement across the entire high school curriculum or entire high school scores. And the areas of strength that stood out to me are that both Algebra 1 and Analytic Geometry showed growth from the 2014, spring 2014, 2015, and then finally to the 2016 administration of these tests, which is impressive given that Georgia Milestones tests are supposed to be harder than previously used assessments. And another area of strength is that we consistently have a higher percentage of Analytic Geometry students who score proficient or distinguished compared to Floyd County schools in Georgia as a whole. That's a positive, and we need to focus on that and be proud of that. And continue to hopefully show that trend. Now, just to wrap up, we talked about a lot of things, but math is so important, and we know that. And if our students are going to be successful outside of high school, outside of their secondary education, we've got to push them, and we've got to help them to be successful and fill in those gaps. So what other areas of improvement or strength stood out to you from the data presentation? Talk about what can we as a math department do to continue this upward trend that is apparent from the last 3 years. And then what can you specifically do in your classroom to continue to increase student achievement scores in these two areas? Whether you teach both of them or not, what can you do to support the increase in geometry, even if you're only teaching algebra? And then what support do you need from the administration so that we can continue to see an increase? They want to help you. We just have to be able to tell them what we need. So what now? Gave you all this information, given you some questions to ask, but what do you do with it? You've got to make it meaningful to you. So I want you to find your EOC data, and I want you to compare it to the data that was presented. If you need help organizing it and figuring out the percentages, I would be glad to help you with that. But figure out, where do you fall? And if you see you're below in some levels, what can you do to fill in those gaps? And if you're above it, what have you done that maybe you can pass on to others around you? Then create a plan. After you think about it, create a plan. Use those questions. What can the math department do? What can you do? What can the administration do to help guide the creation of the plan? And decide how you're going to monitor and assess that plan. We don't want to just do something to do it. We want to do it only if it's going to be effective. And then something that I just really want to remind you of is that we have to focus on the positives. When we believe in our students, they believe in themselves. So we have to focus on what they can already do and build on that. So we don't want to focus on what they can't do. Focus on what they can do, build on that, and hopefully the gaps will be filled in as we go. And then last but not least, I got this data from the following websites: The Tunnel, SLDS, the Department of Education, and GA Awards. It's a government report card site. It was very helpful. There's plenty of data there if you want to do some more digging on your own. But I hope this was helpful, and I hope that you are able to take this data overview and truly see it affect your instruction, because that's what it's all about. Thank you.